Hello, and welcome to Circuit Streams and Niantic's Introduction to Niantic Lightship ARDK workshop and webinar. I hope you're all doing well today. Curious to know, I love asking this question on all our workshops and webinars. Where are you tuning in from? I myself am in Calgary, Alberta, Canada. I see David. David, great seeing you from Montreal, Quebec. Ashish from India. Jeremy from France. Kevin, Brooklyn. Rajan, London. We've got India, Vancouver, Halifax, Toronto. Oh, good day, Tony. LA, California, Florida. Hello from Italy. Hey, welcome, Italy. UK is also quite an international audience. I love to see this. People from all around the world interested and excited about this technology and these tools. I see Hawaii, Colorado, London, Turkey. Love to see it. Well, welcome everyone from around the world. Good morning, good afternoon, good evening, depending on where you're located. Thank you for joining us. Super excited to be here today alongside a few people to share more about Niantic's Lightship ARDK and working together on building a multiplayer experience that you can come out with and show your family and friends afterwards. And really just to kind of, help and wait for some more people to roll in before I kick off the presentation. I'm going to share a quick little video here just to get everyone a little excited. And then we'll get going with the introductions and moving on forward.
Explore like never before with Niantic.
Woo! Gave me the shivers. Well, this would not have been possible without the support of Niantic. So thank you, Niantic, for supporting this webinar and workshop here. A few housekeeping items before we kick things off. As you see to the right there is a chat. Please feel free to chat amongst yourselves, make any comments, share your LinkedIn profiles. If you'd like to network and connect with each other, you're more than welcome to do that. And at the bottom, there's a little kind of bar panel, navigation bar, I guess you could say. Beside the chat tab, there is a questions tab. So if you have any questions for myself, for our instructor and the one who will be leading the technical session today, Jerry, please do toss them into the questions tab. If you have questions for Niantic, because they're backstage and they'll be speaking a bit as well, toss them into the questions tab. It helps us see what hasn't been answered, really keep it organized, and get to it at the end for the Q&A session. Now, beside the questions tab, we do also have a polls tab. So I'll toss in polls throughout the webinar just to gauge the experience of the audience. For instance, I'm going to toss in a poll right now. So feel free to go to the polls tab. I'd like to know, what devices do you own? So I just published the poll. Feel free to check it out just so you can get familiar with the polls tab. I myself have a Quest 2, both an iPhone and an Android. I've got the Quest 1 as well. And that's really the extent of it. I've really got to get my hands on some more devices out there. But looks like lots of Androids as well. Oculus Quests, iPhones, Go, Rift, HTCs, Valve Index. All right. The Lamborghini of headsets. I like it. Google Glass. An oldie, but a goldie. Perfect. Love to see that what everyone's kind of, holding or using these days. But with that, let's get this show on the road. I'm going to slowly start doing some introductions here. I myself am named Stefan Licina. I lead partnerships here at Circuit Stream. I have over 7 years of experience in the tech industry, working with travel IT companies, learning management system providers, ERP and business integration platforms, and now in the beautiful world of AR, VR, and MR. So that's augmented reality, virtual reality, mixed reality, real-time 3D technology. And an interesting fact about myself, I was a member of Water Polo Canada. I trained with the Canadian Olympic team. I never got to go to the Olympics, but I used those skills to save a couple that were drowning in Mexico several years ago. But with that, it's a pleasure and an honor to have my colleague Jerry Medeiros join us. Jerry is the Director of Education here at CircuitStream. He has over 12 years of industry experience, game development, immersive tech, and he himself holds a Master's of Science and Business Administration, Computer Science, Leadership, and Innovation. So, an absolute gem, a man that is, the one of the wisest people that I've ever come across. And it's a pleasure to have him really show you all how to kickstart your own multiplayer project using the Niantic Lightship ARDK. And I'll pass it off to Chanel here from Niantic to introduce herself, touch up on the next slide as well, and then I'll get things rolling afterwards. Great to see you, Chanel.
Yeah, thanks, Steph. Good morning, everybody. My name is Chanel Pingdi. I'm a program manager at Niantic. I work specifically on Lightship community events. I have a master's in learning design and technology, and that's kind of where I love showing my passion and bringing you guys great learning experiences like this today. And next slide, Steph, if possible. So just some quick announcements. We have a few upcoming events. September 15th, it's on a Thursday. It's different from our normal weekly Tuesday events, but it's at the same time, 11 a.m. to 12 p.m. Pacific Standard Time. We will be hosting a product session on Lightship VPS. And to follow up with that, we also are accepting applications for our VPS Developer World Tour. We're heading cities all around the world: London, Seattle, New York City, Los Angeles, and Tokyo for hackathons. So if you're interested, please apply on our website there. We're also going to be launching monthly mini jams, and that's going to be coming out next month. So check out our Discord, and if you haven't joined our Discord, the QR code is right there for you to scan. And thank you. Back to you, Steph.
Thank you, Chanel. And I'll be sure to bring up this QR code later on as well. But I'll take 10 seconds for anyone to whip out their phones, tablets, just to scan that QR code. Join that Discord. Massive, super helpful, great community there. And Chanel, thanks so much for sharing all of this. I'll be sure to refresh everyone's memory about this later on as well. Perfect. So with that, let's continue on here. So today is going to be quite a jam-packed webinar and workshop. I'm going to do a quick introduction to CircuitStream for those of you who are new to us. Then I'll dive into the industry. What can we expect with this industry? Where is it going? As well as an introduction or an overview of augmented reality for anyone who might be new to AR, but still curious to know about these tools out there and to start building their own projects. Then I'll invite my colleague Jerry onto the stage to do that deep dive to help you all create a multiplayer project alongside him. That's going to take about an hour and a half or so, 90 minutes. But there will be breaks. We'll go slow, make sure everyone's able to catch up. If not, this will be recorded and posted afterwards. So don't worry if you're falling behind. We'll take breaks. We'll slow down. But however, if you're falling behind, don't worry. You'll have something to work with afterwards. So ask questions. If you do fall behind, sit back, absorb everything, ask questions, and both the Niantic and CircuitStream team will be happy to help any way we can. Once Jerry's done creating that project alongside you, we'll dive into some of the courses and programs for anyone who wants to upskill and gain the skills to take this further. I'll wrap things up with some resources, and then we'll open it up for a live Q&A session at the very end. So if you do have questions, toss them into the questions tab. It'll be super helpful and helps us really organize and get to things efficiently. So who is CircuitStream? Well, CircuitStream is an education company focused on helping people get the skills to develop and design real-time 3D experiences. We started in 2015 when everyone was on the hype train for building projects and experiences, but there was no real means of learning how to do this themselves. There was a gap. So we came in 2015, and ever since then, we've had a focus on education, and we've had the pleasure to reach over 45,000 learners worldwide. So honestly, a pleasure to reach as many people as we have so far, and looking forward to reach even more. Now, CircuitStream is also a Unity certified programmer, as well as professional programmers, Unity authorized training partners. and all of our instructors are certified instructors as well. Now, Circus Stream is one of the only schools out there and online institutions that provides micro-credentials, and we actually worked alongside Unity to co-create the Certified Associate Programmer certification. Now, we've had the pleasure to reach, again, over 45,000 learners worldwide, and to work with some of the most forward-thinking and innovative companies out there. And here you can see some of our learners and the companies that we've had the pleasure to train and teach. Now, not only do we train and help enterprises and small businesses, but we also partner with universities to deliver our courses and programs to their communities. So if you're in any of these areas, please don't hesitate to reach out to ourselves or to the universities there. You can take an XR development, design, or other courses and programs out there through the university to also get a certification from the university. So if you're in the area and interested about any of this and want to upskill yourself, feel free to check out one of the university partners we have here and get a certification from them as well. So again, we train enterprises, we partner with universities, but we also teach individual learners like some of you here today joining us. And we've done this through 3 main courses and programs: our XR developments with Unity, 10 weeks, beginner friendly, all live and online instructor led. Similarly, an XR design course, also 10 weeks, beginner friendly, live and online. And then we have one that's more career oriented, the Unity Developer Bootcamp. And this is 24 weeks long, much more intensive. You do need some foundation or fundamentals before diving into this program, but really there to help you kickstart a career in this industry and space. But I'll touch up on these a little bit later. And we've loved to see where our learners go afterwards. We've had for 3 consecutive years students get into Oculus's Launchpad program and receive further support and sometimes funding to continue the projects they started off with Circus Stream. And then we've even helped so many people land roles at various organizations after they've taken a program or courses with us, from Bungie, Electronic Arts, Microsoft, Meta, you name it. We've had people join various different organizations after they've learned the skills to be successful. Now, we do have an AR multiplayer development with Niantic Lightship short course. I'm going to touch up on this a little bit later on as well, but this is scheduled for September 10th. Join the waitlist if you're interested, even after this webinar and workshop, to dive into Niantic some more alongside Circus Stream. September 10th, we have a short course scheduled. So please, if you're interested, join the waitlist, reach out to the team to learn more, but I'll share more about the program later on today. So now that you've learned a little bit about us, what are you going to learn here today? Well, today we're going to show you what projects you can start building with Lightship, what Niantic Lightship is, and why it is important for AR development. We're going to touch on Lightship shared AR experiences, and by touch on, I mean we're actually going to create a project altogether in 90 minutes. The basics of setting up multiplayer capabilities via ARDK, how players can synchronize data, how to integrate networked session between clients, and building a prototype of a multiplayer tower building AR game. So super exciting. You're going to come out with a project to show for afterwards. And again, if you fall behind, no worries. We'll all work together. This will be shared afterwards. So if you do fall behind and you can't catch up, you'll get something to work with, but ask questions, absorb all the material. That's probably the best recommendation I can offer. So touching up on the industry, where is this all going? Well, there are so many industries embracing this technology. And I like to say that almost any industry out there, or all industries out there, can use this technology in one way or another. So here we see media and entertainment. Retail is a huge one. Architecture, military has been using this for years, even before it was accessible to us. Fashion, education, manufacturing, you name it. But the list goes on. I really say that this can be applied everywhere. So super exciting technology. And geographically, the trends are growing as well, right? Countries around the world and continents around the world are increasingly adopting this, especially in light of the pandemic that's been happening. This really kicked things off, and there's been a big push for kind of virtual interactions and engagements, and we're seeing that across the globe as well. And I love to share these facts and statistics here. Price Waterhouse, in their Seeing is Believing report, mentioned that almost 24 million jobs worldwide will be using augmented and virtual reality by 2030 for training, collaboration, and to provide new digital experiences. Now, they also said that VR and AR have the potential to add 1.5 trillion to the global economy by 2030. So again, so much growth potential with this industry and technology, and it's great to see people from all around the world tuning in to learn more about this. Now, Dayon did throw something into the chat here, my colleague Dayon. If you should have received Jerry's project assets in an email prior to the workshop, but if you haven't, Dayon did share the project assets to download with a link there. So do check it out. Go to the chat there. Click on the link, download it if you haven't downloaded it already. So we'll still have some time before we get into it. Now, learning XR skills is an advantage. So Hire.com mentioned there was 1,400% AR and VR job growth in 2020, 601% demand growth for real-time 3D engines, and $20,000 increase in salaries with Unity skills supposedly. So again, the value of these skills are huge, and again, with the trends of how the industry is growing, I see this as being a friendly future. Now, some interesting stats that I found recently. So Pew Research Center, the Metaverse in 2040 report, just a few weeks ago that a colleague of mine shared, mentioned that according to the World Economic Forum, the lack of digital skills among their people cost 14 of the G20 countries 11.5 trillion. And it also reported that by 2030, US talent shortages and skill gaps could cost its economy 8.5 trillion. So it's great to see everyone here, wanting to learn more about this, getting excited, interested. The future is friendly, so much growth potential, and we're in a good position, seeing that there is potential lack and talent shortages on this side of things. So what is augmented reality? So for those of you who might be new to AR, augmented reality is known as, again, AR, and allows for virtual items and information to be overlapped in the real world. The user can use AR glasses or even use any digital screens such as smartphones and tablets. And by using these items, the user is not isolated from the real world around them and can still interact with and see what is happening in front of them. So the most well-known example of AR is Pokemon Go, the game that overlaid digital creatures onto the real world. So thanks, Niantic. Or Snapchat, for instance. Snapchat filters that put digital objects such as hats or glasses onto your head. So I'm going to toss in another poll here, because I know some of you, are fairly experienced with augmented reality. So I'm going to toss in a poll. Please navigate to the polls tab. I'd like to know, how familiar or experienced are you with Niantic Lightship ARDK? So I'm going to publish the poll. It's been published. Let me just see. So 10, you're an expert. You're a Jedi Master, the Chuck Norris of Lightship ARDK. 1, you're a beginner. You just heard about ARDK. So very curious to know where you're at. And this will also help my colleague Jerry tailor the technical side of things afterwards. But talking about the evolution of AR there, I do like to say that we are, I like to compare it to the evolution of the mobile phone. So when kind of mobile phones kicked off, we had these large brick-like phones that you can break down walls and buildings with. But as years went on, the hardware got better and stronger, the software got better and more effective and efficient, and devices were just more convenient to hold and to Use. I'd like to say that they got smaller, but with our smartphones today, they're they're quite large again. But nonetheless, so this is how I like to compare the evolution of AR. And where are we today with AR? Well, I'd like to say that we're at that first generation iPhone moment. I'd like to potentially move this down back to the Samsung mobile one. Why? Because there's still so much room to grow with augmented reality. Having more convenient devices out there. The software's got to grow more, and it depends how you're looking at this. If we have brain machine interfaces and augmented reality working with that, I'd like to say that we're about at that iPhone moment there. So move the arrow back. But with that, this is the first kind of augmented reality experience that was captured. So this one's hanging off the ceiling. So you are kind of stuck in one place, but information was overlaid with this device here. Then it was the military. Military, big budgets, lots of money, so they got their hands on this technology way before the public did. But with this, we have our AR devices here today. This is just a joke, just an iPad stuck to someone's face. But we've got the HoloLenses, and the future is friendly with other organizations out there looking to create AR glasses and even more powerful phones for mobile experiences. It's going to be great. And the augmented reality market size worldwide in 2017 and 2018 were just a fraction of what is forecasted to be in 2025. This says, what is it? Billion. So 198 billion by 2025 for market size. So big potential with this technology here. But with this, for those of you who want to see how AR can be applied in some areas and others, this is one that the news uses for augmented reality. It's just an example of what AR and some of the use cases of AR can be.
Look at this car. We're after the storm. The roads have been cleared. We're ready to get back out on the roads. Let's bring this car out, actually, into augmented reality and show you what I'm talking about. Because you hit the roads are clear. Visibility looks great, right? You think there's no problem. But then you get behind this guy. The one that doesn't clear the snow and the...
So, an example of augmented reality in action on TV by the news. So again, you can apply this to so many different industries and areas. And it really looking forward to seeing other areas that we apply this that we don't see today. But with this, let's get this show on the road. I'd like to invite my colleague Jerry Medeiros onto the stage, our Director of Education here at Circus Stream. Again, a pleasure and an honor to have Jerry join us here. Jerry, how are you? And thanks so much for joining.
Hello. I'm good. How are you?
Doing very well. Jerry, before you do kick things off, I have one last little video to share. Just a little, Niantic hype up, and it's a multiplayer, video that I'll be sharing, just to give an audience just another idea as to what is possible with Niantic's tools. Is that all right, Jerry?
Yeah, sure.
Perfect. So I think it's only a minute long or so. So here it goes. Oh. Ha, nope. Silly me. Already shared this one. There it is. All right.
In 5G cities across the world, stories are unfolding.
Amazing. No, such great tools by Niantic, and Jerry, really looking forward to you showing everyone how to kickstart their own experience and come out with something they can show for as well.
All right, sure. Can everyone hear me, see me well? Just say yes, no.
So I can. Let's wait. So David says
Okay,
yes.
see some thumbs up there.
Yep, perfect.
Amazing, cool. So I think we can get this started. Yeah, thanks everyone for having me today. This is super exciting. I see you soon, Steph. Um, Lightship is a very nice tool, super cool tool, and I think everyone enjoys what we're gonna see here today. Before we jump into Unity and in the technical piece, I just want to share a couple things to make it a little bit easier for us. So let me share my screen here, and let's go over what we're gonna learn and what we're gonna see. So first thing, today it's all about AR shared experience, which means it's gonna be a multiplayer experience. You have multiple people in the same environment. Everyone is in their own devices and they're seeing the same things and they're playing together. So this brings lots of complexity into the game because doing multiplayer is really complicated most of the times. I'm gonna try to make it as easy as I can, but this is super cool and super powerful. You saw the video that Steph just shared. You have like multiple people playing together. That's what shared AR experience enables us to do. And using Lightship nowadays is the easiest way to do that. You could use any other platforms and try to integrate AR plus the multiplayer piece. It's gonna be really hard because you need to have good tracking and all that. So with the ARDK, you can do everything there. So it's a lot easier than any other combination of tools. Before we jump into some tips and considerations, I want to show you what is the experience, what it looks like, and walk through what entails, so it makes it easier for everyone to understand what we're doing. So I have a video here of the thing we're building. So let me play that video. Let me pause here real quick. So those are two devices, two different iPhones. I have them here. So basically I build the things in two different devices and I'm testing with myself in my room here. So basically I joined those two in the same environment. They're playing in the same shared space. So what one player instantiates in the environment, the other one can see. We can sync those two things. We're going to see how to do that. We can see that on top, I'm using this phone on the right to record the one on the left. And then there is this sphere here following that phone. So basically, the position of the other player is also always tracked, and we can know where the other players are in the environment. So we're going to see how to do that as well. And then we have a little game here, which is a tower building game. So both are playing at the same time. One's playing on the red area, one's playing on the blue area. The first one to build the tower up to the top is the one that wins. So you can see my cat is here trying to play too. And then it's all synced. One player knows what the other is doing and vice versa. And then when someone wins, the message is communicated through the network and then the game ends. So that's all they're going to be doing. It seems like it's simple, but it's a lot. But if you can get the concepts and how those things are built, you can go from there and build any other multiplayer experience you want to build. So I'm going to be covering handling connections, handling data when it's received, serializing and sending data, synchronizing states. So that's basically the bread and butter for you to build multiplayer applications using Lightship. So that's what I'm going to be doing. So let me stop sharing this thing and share my screen again. Share screen. I'm going to share this screen here again. And let's go over what we're going to be doing and the order. So you don't get lost in there. What's going on? This thing is just moving without me touching anything. What's that? Stop there. Okay, I think it did. So we're going to be doing a little bit of setup. So creating some objects, some interfaces. So a join button, things that we need, a couple prefabs that we need to instantiate. So the first bit is going to be no coding, just organizing our scene, understanding the components, what they do and what they're used for. Then we're going to go into subscribing networking events. How do I know if someone joined, if someone left, if someone sent me some data? What stage is this person in? Are they connecting, synchronizing? Are they stable? So we're going to be seeing what those states mean and how to manage them. Then we're going to create the game rules. For example, we can only start if there are 2 players, the players are good to go. And then we're going to code a little bit of the rules of the game, and then keep synchronizing these states between player, what they're doing, where they are, if they won, if they lost, things like that. All right, let me just see so the questions. If you have questions, there are more philosophical big questions. You can put them in the questions tab. Indica is helping. I can answer a couple of them in the end as well. If you have more immediate questions, you can use the chat tab. I'm going to be looking into the chat more often. So that's what we're going to be doing. That's what we're going to be building. And I have some housekeeping expectations alignment before we dive in, so you don't get lost or frustrated in there. So the first thing is, writing multiplayer applications is always complicated. It's really, really complicated. It doesn't matter which tool you're using. It's always a lot of considerations, because you have multiple users in multiple places with multiple devices. They're connected to the internet. They can leave. The internet can cut. Testing is really hard because you need to build into 2 devices and have someone testing it with you, or testing yourself with multiple devices. So it's not easy. If it's getting too tricky for you, don't well, you can keep watching, keep asking questions, try to focus on the concepts, and then you're gonna have the project that I built with comments that you're gonna receive, and I can share the link in a while here, and you can try to go and understand what's going on in there. You also have the recording, so you can pause and redo. So if it's getting too complicated, make sure you ask the questions, things you're not understanding about the concepts in there. Another thing, I mentioned that already, but testing in multiplayer is super tricky. So I'm going to show some tips on how to make it a little bit easier, but ultimately you're going to need to build into multiple devices to make sure you have, you can test the real experience in the end. So testing is really hard. I needed to have like a bunch of devices here, testing the things. During the workshop, I'm not going to be building to the device very often because it takes time. So I'm going to build in the end and show how it looks like. But I'm going to show a couple of tricks on how to test more effectively. But one thing you need to know is, if you want to test this in the end, you need someone else with a mobile phone with the same application to have the full experience. Another thing that I want to highlight is that today's workshop, because it's multiplayer, it's going to be a lot of live coding. So I'm going to be writing lots of code. I organize that in a way that it makes sense, that it's clear and organized, but there's no other way around it. Otherwise, we cannot build a multiplayer application. So I'm going to try to describe them as plain English, how the things, what's happening, what we're doing, and why. But it's going to be a lot of flight coding. So my recommendation is, if you don't know how to code yet, if you don't know C#, it's something we're still working on, focus on the concepts that I'm explaining. What is the host? What is the peer? What's serialization? Why those things work the way they work. And then once you are more comfortable with coding, you can come back here and you know what's going on. So if you're an experienced coder, that's all right. Or if you know how to code a little bit of C#, that's fine. You can try to follow along. If you're not, I recommend that you open the project that's already done and just go over what I'm doing. Don't try to type plus understand plus ask questions all at the same time if you're not familiar with coding. And just a reminder that the scripts are shared. I'm going to share now again a link with everything in the project. So there is this GitHub link here where I uploaded the complete finished working project. You can go there and download it. So you can just go here, code, and download a zip. There are only 2 classes. There are here under scripts. So one is the game manager, one is the spawner. Most of the things are in the game manager. You can see that I put comments for everything. I'm explaining what's going on. So you can use this if you want to, see what's going on and catch up in there. All right, so that's what I want to say before we get started, because those things are, they're important. So everyone is on the same page and you know what to expect. Now let's get the things going. Let's get started. I'm going to dive into Unit. So I already have here my project. And the only thing I have in this project is the ARDK imported. So you can go to Lightship, sign in, it's free, download, and then you're gonna have the same things we have here. Another thing that is important is the authentication. So you need to have created the authentication asset here. This has a code that you can get from your dashboard in there. So we send a video previews on how to do those things, but it's just like importing and having the authentication here. If you don't have that right now, the authentication right now, you can add that before you build, but those things are important. They need to be here so the project works in the end. All right. So let's get started and let's start building. So the first thing we need to understand when we're dealing with AR is that this main camera that starts here with Unity, this main camera is not an AR camera. It's a virtual 3D camera. So I'm gonna delete this. I'm gonna get rid of this one. And we're gonna bring a different type of camera here. So the way the Lightship AR SDK works is with some managers. So it has different managers for different things. So if we're working with plane tracking or localization, you're gonna use different managers. They already have a couple of prefabs that you can find under ARDK extensions prefabs. So here you have some prefabs that we can use in different situations. I'm gonna start with this AR scene manager, and then we can go over what are the fundamental, most important components we need to have. So I'm gonna drag this AR scene manager component into my scene. In the AR scene manager, I have a couple of things here. So the first one is the AR session manager. What this component does is basically initializing an AR session. It knows that this application is going to be an AR application. It's going to request access to the user camera. It's going to instantiate the word origin and start tracking. So every time we are building an AR experience, we're going to need to have some kind of AR session. And in ARDK, this is the one we use. There are a couple of options here. We're going to come back and change later, but let's keep building on top of this one. The second one is the compatibility checker. So this is a very nice component. We're not going to touch on that in depth today, but what it does is just checking if the device can do things. So does this device has a depth camera? Oh, yes, no. Does it have a GPS? Yes, no. So basically you can code your experience based on the capabilities of the device, or you can just tell the user, hey, you cannot run this application because you have a very old phone that doesn't support this kind of application. So this comes by default here. You can add some events here to add an interface or anything you want, but basically this is the capability checker. So if I just build my application right now to my Android, what is gonna happen is it's gonna request my camera, it's gonna open my camera, and I'm gonna see my environment. Nothing else is happening visually because we didn't do anything, but this is basically an AR application already. That's all you need to have your AR application up and running there. Because we're dealing with, oh, and another thing, I said we need to delete the camera because we're gonna be using an AR camera. It's already part of the scene manager. So this has another camera that is black, just renders black because this is gonna be replaced with the camera feed. And then we have here a couple of components, rendering manager and position helper. So this is basically the main setup for us to have an AR application there. Is the resolution all right? Can you see and read? Is it all good? And someone say yes, no. Should I try to change size? I see some thumbs up. Okay. Some people say it is not the best, a little bit blurred. As long as I modify my screen layout. Let me try to reduce my resolution a little bit and see if it helps. Oh, I'm gonna try to make this a little bit lower resolution, which is not very good for me. but it might be better for the recording. What about now? Is it any better? Woo. What do you see? Oh yeah, all right. It seems like it's better. Can read better. Okay, so I'm gonna just be with this larger weird resolution for me, but if it's the best for everyone, I think that's okay. Cool. So it's getting worse. It's getting better for some people, worse for some people. I don't know. Just do full screen and that should do it. It's viewable. All right, cool. Let's keep with this one and hope it's the best for most people there. So now we need to add a couple more components to the scene manager. So the one we added right now was just the basic AR session. It's going to handle the AR session. And we also have the capability checkers that just comes built in here. Another component I'm going to add here is a plane manager. So I'm going to search for AR plane manager. What a plane manager does is basically allow me to track planes in my environment. So if I'm moving around with the camera and then I have a table or a floor or a wall, this is gonna be recognized by the AR session and by the AR decay, so I can use those planes. We're gonna be using a plane later to instantiate our game board. Our game is gonna run on the floor or on a table, wherever the host selects, but we need to track the planes in there. So the way the plane tracker or the plane manager works is I need to tell it what kinds of planes I want to track. So I can say all of the planes, no planes, just horizontal or just vertical. So in our game here, for example, if I don't want my user to place anything on the walls, I could track only horizontal planes. So it's going to make sure it's not tracking walls or things like that. So that's how it works. That's basically how it works there. And that's all we need to do. If we want to visualize the plane just for debugging, or if you want to like create a texture in the plane, we can add a plane prefab here. So I'm going to do that just for debugging. The Lightship SDK already provides one prefab that we can use. So if we go under extensions, plane finding, there is this debug plane. So this debug plane is basically like a plane we can use. There is also this plane prefab that I like more. This one uses a it uses a shader that can shows the plane, so we can use it. So I'm gonna go back here in my session manager and just drag this plane prefab into my plane manager component. So now, if I build this application, what's going to happen is it's going to request access to the camera, and it's going to start drawing this plane prefab on the horizontal planes that it finds. So my floor is going to start to become, well, shaded with this prefab in here. So that's all happening right now. That's basically what we have in there. But we already have a nice, simple AR application. So let's keep building on top of that. Another thing I want to add to this AR session manager, because we're dealing with AR multiplayer, we want to do a shared experience, we need to add the components that are related to that. So there is a network session manager. So what this network session manager does is basically transforming this AR session into a shared experience AR. It does a bunch of things. It handles networking, it handles events, connection, disconnection. We're gonna see how to do those things in code. And one of the important things, it has a session identifier. So the first concept that I want you to take note and understand is the session identifier. If I have an application, it's this game here. And how do I connect two people together? If I want to play with my friend, how do I make sure we are in the same room, we're the same application playing together? We need to use the same session identifier. So the session identifier can be anything, any text. It just cannot be empty. And we can even create an interface for the player to define what they want it to be. So we're going to do that later today. you can relate to many multiplayer games. You have, for example, I can't remember the name of that one that you need to find people and murder them and hide. Now the name of the game is not in my mind, but you can share code with your friends and then they join the same room. So that's basically what this identifier is going to do for us there. And together with the session manager, we also need to have a networking manager. So the networking manager is going to provide a couple of events too. So those are all of the components we need to make this start being an AR with plane tracking and multiplayer capabilities in there. Another thing we're going to need to add, and this is only for Android. So if you are planning to build for Android, you need to add a permission requester so the application can ask the user if they allow you to use their camera. On iOS, that's done in a different way. I will show later. But for Android, there is a component called Android permission requester. So you need to add this if you want to build for Android and make it work on Android. And then we need to add a permission to the list. So I just click on the plus button. And they have a couple of permissions here, depending on what we're doing. For today, we only want to request camera permission. So what this component is going to do is when the application runs for the first time on the user device, it's going to request access to the user camera. And if the user says no, I'm sorry, you cannot play. If they say yes, then the AR session starts. So now we have everything we need to start. Among Us, yes, thanks for people there. That's exactly the game I was trying to remember. It's Among Us, yes. So you can make your Among Us. There is AR, why not? And well, that's gonna be busy. You're gonna need to have lots of space, but yeah, that's the game I was trying to remember. Cool. So now we have all of the components we need. All of them are in place. We're gonna need some modifications to those components, and I'll explain why real quickly. So one thing we can notice here, if you look into the AR session manager, if you look into the network session manager, is that they have this option called manage using Unity lifecycle. So if those things are enabled, what it means is that the ARDK is going to define when to initialize, when to destroy the session based on Unity events. So on awake, it does something, on start, it does something. We don't want this because we just want to start that when the players are ready, when we're sure we can start the game. So in the AR session manager, I'm going to disable the manage using Unity lifecycle. I am going to do that in the AR networking, in the AR networking session manager as well. AR networking session manager as well. So, oh no, yeah, here and here too. Now this one, actually, I want to keep this one. I will disable this component. So just recapping here, on the AR session manager, I disable the manage using lifecycle. On the network session manager, I also disable that, and I disable the AR networking manage completely. This is because if I have this component enabled in the beginning, it's gonna start doing things before the user is ready. So only when the user presses join and everyone is ready to go, we're gonna enable this based on when the player is ready. So this makes things a little bit easier because if you have all of them managed by the RDK, you're going to have weird behaviors. Like the session is going to be created and the other player is not ready yet. So the way I think it makes more sense, the way I have been doing that is just keeping those disabled, and we're going to enable them based on when the player starts the game. Cool. So let me get back to the chat here just to see if there are any questions, outstanding questions, things I could help with. I see that Indica is helping there. Okay. Cool. So with this, we can start building our objects. So first phase is done. With this, we already have an application that can manage AR with plane tracking and with multiplayer capabilities. So that's all we need. Now, what I'm going to do is start creating a couple of objects that are going to be useful for us here. So we're going to create an interface with a join button, with input text, so the player can place what session identifier they want, and we're going to be creating the board for the game, and then we can move into the coding phase, which is going to be the next one. So let's get started with creating a little bit of the interface here. I'm going to create a canvas. I'm going to go here on UI and then canvas. And the canvas in Unity is basically where we place buttons, text, and things like that. And in this canvas, I'm going to add one input text so the player can place or can type the session ID that they want to join. So I'm going to create a text here. UI and then text. Oh, it's not text. I'm sorry. So this is a static text. Actually, I want to create input field so the player can type. So this is an input field where the player can type. Let me move this to an aspect that looks a little bit more like my mobile phone. So this is 16:9. I actually want 9:16. There we go. And I will position this somewhere here. And I will anchor that on the top. So if I move this screen, or if we have like different devices with different sizes, it's not a big of a problem. Actually, if it's too small, it's not going to work, but it's not that important for now. And I'll also create a button that I will call join. And I will move it a little bit up here. And I will pivot that into the top. So now I have a button for the player to enter the session ID and a button to join. Another button I want to create here is a button to start the game. I'm going to go into UI and then button, and this one is going to be to start the game. And let me anchor that on the bottom. This is going to be join, just changing the text, and this is going to be start the game. So to start with, the start game button is going to be disabled because I can only start the game when everything is ready to go. So right now I will keep this one disabled, and later on, using some code, we're going to enable it when everyone is ready, just on the host. So we're going to get there soon. But now, for now, I'm going to keep this one disabled. So this is everything we need for the joining interface, and then we can get started. I'm going to create another canvas, and this one is going to be for the end game. When the game ends, we can enable that and tell who won, who lost. So I'm going to create another canvas. And the reason why I'm going to create a different canvas is so when the player joins, we can disable this completely, and then we can enable the other one completely. So if we create everything together here, it's going to be harder to enable and disable components for different phases of the game. So this is for the beginning of the game, and the other one is going to be for the end of the game. So I will create another canvas here. And this one is going to be end game. Let me call this end game. So in this one, I will just create a panel. So a panel is just like a visual representation. You can group things together. Just create a panel here. So it has like a little bit of an overlay. And then in this panel, I will create a text, because later we're going to place in this text if the player won or if they lost. So basically, let me increase the font size a little bit and organize. There you go. It doesn't need to look pretty for now, but this is gonna enable us to tell who won. And this one is gonna be completely turned off too. We're gonna turn it on later when when someone wins. Cool. So now we have all of the interface we need, and we could jump into the code. But before we jump into the code, let's create the board of the game. So I'm gonna show you how I created that. I will create an empty game object here just to hold the whole board. And the way it's gonna work is we're gonna have one area for one player, another area from another player. The way I did that was with 2 cubes. So one cube is just an area for one player, the other one's for the other player. So I'm gonna convert this into a prefab. Let me create a folder here. It's for prefabs. A prefab is something I can instantiate later. So let me drag this here. Now it's a prefab. We can edit this prefab. So I make sure it's on the 0, 0. And here we're going to create 2 cubes, one for player 1 and one for player 2. So I will just create a new cube. Actually, let me edit the prefab directly. It's going to be better. So what I did here, instead of editing that here in the scene, I will edit the prefab directly. Just double click the prefab. So we have a little bit more space here and we can only see the prefab. So I'll create a cube. And this one is going to be the area for the player 1. One thing we need to notice when we're dealing with AR is that when we instantiate those, they're gonna, the scale is really important. So the size they have here is the size they're gonna have in our room or wherever we are playing. So here in Unity uses the metric system. So this is 1 meter by 1 meter by 1 meter. So I will go and make it, I don't know, 3 meters tall or 4 meters tall. You can define that based on the spaces you're planning to have your player playing or something like that. And I will duplicate this one to be the player 2. So you can space them out as you want. So just remember that this is going to be instantiated in your environment. So in your room or wherever you are. And they're going to have the same size. So this is going to be 1 meter width by 3 meters here. So it's gonna like almost occupy all the height of my room. But that's basically how it's gonna work in there. We also need to have a spawn point, like a place where we create the cubes. So if you remember in the video, every time we touch, it's gonna create a cube and spawn that cube with a rigid body. So we need to create a spawn point from where those cubes go down for each player. So I will create an empty here, and this is gonna be the spawn point for player 1. So I'm gonna drag it all the way up here. So when I position it or where I position it, that's basically the position where the cubes are gonna start dropping. So if you want them drop from lower, from upper, you just need to move it here. If you want to give it an extra challenge later, you can animate this point. So it instantiates from different locations, but I will start just with a simple using it up here. And then I will create another one. For the player 2. So this is going to be for player 1. This is going to be for player 2. I think I made it 6. Just made it a little bit up here. Cool. So this is going to be our board. That's almost everything we need for our board. Another thing I did, just because if I instantiate the cube and the cube fall here, we're not gonna be able to see them because this is opaque. So what I did, I created some materials. So I'm gonna create a folder for materials. And a material is basically a description that we can use to change colors, textures of things. So here I'm going to create two materials, one blue and one red. So I'm right-click, create, and I'll select material. This is going to be the red material. And I'll create another one, create material, blue material. And then we can change the colors. So first thing, because I want them to be transparent, here where it says opaque, I'm going to change it to transparent. Here where it says opaque, I'm going to change it to transparent too. And then this one, I can change the color to red and add some transparency, maybe a little bit more. 56, that's what I use. And here, it's going to be 56 as well. Oh, I made both red. This one should be blue. There we go. And then I can drag them here and here, or the other way around. Cool. So now we have most of our board, and that's what we're going to need here. Later, we're going to come back to this board and add some coding to make this board work a little bit more properly. But now, basically, we have everything we need. So we have the interface that the player can write the text with the session ID and join. The start button here, we can enable and disable later. We have the end game that we can enable and disable. And we also have our board with the materials in there. So we have 70% of everything we need. Cool. So now we're going to get into some coding. One thing I forgot, we created this text here for the session ID. We need to reference that into the networking session manager, because we can either type it here or we can drag it here into the input field. So because we already have this input field, I can just drag this input field here. So with this, automatically the ARDK is going to pick whatever the player types here and use that to join the session. So now we're going to need to jump into coding. And I'll make sure, or I'm going to try to go as slow as I can explaining what's going on. If you can understand the concepts later, you can come back to this and iterate there. So I will create an empty game object here that I will create, and then I will call game manager. You could drag the script to other objects. That's not a problem. But just to keep the things a little bit more organized, I'm going to create it here. So I will create another folder just to hold my scripts. And I will create a new script that I will call game manager. And I'll drag this script into my game manager game object. There we go. Now I have a game manager. When I hit play, this is going to run because the script is here. Now we can start playing around with this script. All right, so for now, this script is pretty plain. It doesn't do lots of things. We're gonna need to have a couple of references here. And this is where it starts to get interesting. So we can listen to events. So basically what we wanna do is we wanna listen to events. We wanna know when the player joined, when the player disconnected. So here we need to have references to a couple of objects. So the first object that we need to have reference to here, and I'll create a variable of the type, is the AR. Actually, let me make this private and then we can go over that. AR networking, and the names are a little bit big, but the good thing is that most of the times this thing helps us out to complete, not always. So this is the AR networking manager, and then we can give it any name. Oops, manager. AR networking manager. So this is a reference. Oops, now the things are so small that I cannot see. There we go. To this component, AR networking manager here. So we need to have a reference to that. In order to be able to use that in code, we need to import. Did I type that wrong? AR networking manager. Yes, I did type that wrong. Manager. There we go. So we need to import the Niantic ARDK extensions. So we can just type here using Niantic ARDK extensions, or if we're using Visual Studio, most of the times, if it doesn't recognize a class, you can just go here and use the helper to import that for us. So this is the first reference that I have. This one, I'm going to need to drag from the inspector, so I have a reference to that. So I'm going to add the attribute serialized field here. So what this thing does is basically allow me to see this reference into the inspector. So if I go back into the inspector, when I select my game manager, now there is a slot here for me to drag AR networking manager. So we can just drag this component here and it's going to pick up the correct component. So now I have a reference to the AR networking manager in my code. Steve said, I will revisit the recording too. I missed a big chunk. Yeah, no problem. That's the best thing, actually. Try to focus on the concept so you know what's going on and you know what to ask, what the questions you should ask. And then later you can get the recording and pause and redo that. That's the best way to learn how to do this thing, especially when it's complicated. But take the chance to watch, try to understand what's going on and ask the right questions so I can help you with more conceptual questions, what those events are for, what those components are for, and then you can focus on the code later. Also, I shared the code and I'm going to share that again. If you don't want to type it now, but you want to see like what I'm typing, you can just download the scripts and they have comments. They are there. You can see what I'm doing. So you don't need to type, but you can go over what's in the scripts in there. So I just shared again the project. You can download it and see what's in code. Maybe I'm going to type something in different order, but it's going to be mainly the same thing. But I think that's the best way to go over the material and make sure you're understanding what's going on. Cool. So now we have a reference to the AR networking manager there. Another thing we need to have a reference to is an IAR networking, and I'm going to call that just AR networking. So this is another component we're going to need to have a reference to. And this is in a different package. So I also need to import Niantic ARDK, AR networking. So now I have a reference to the networking components. So I'm going to add a comment here. This is a reference to the networking components. There we go. As we progress with the game, because it's a multiplayer game, the way the AR networking is going to work here is peer-to-peer. What does that mean? Is that there is not a centralized server everywhere or anywhere. There is processing the logic most of the times. So we're going to have two different types of players. One player, only one, usually the one that joins first, is the host. So the host is like the main device that is processing most of the logic. And all of the others are peers. So those are two concepts that are important when we are dealing with multiplayer. One is who is the host and who are the peers. So here, I'm going to have a reference to the host. If I need to communicate something to the host directly, we can hold a reference to the host. So the type is called iPeer. So I'm going to call this one the host. And to have access to this, we need to import something else, which is the ARDK networking. So those are similar, but they're not the same thing. You don't need to memorize that. If you just type iPeer here, if it's not being recognized, Visual Studio lets you know or helps you know what you need to import. So I'm going to have here a reference to the host. And I also want to have a reference to myself in the network. So I'm going to call this one self. So you can have a list of all players, but in our case here for now, just having a reference to the host and a reference to the self or myself in the network might be enough. And another one I want to know, or another thing I want to know most of the times, is if I am the host or not. So if in my device is being the host, it's going to need to do some extra work. So I'm going to keep a Boolean here just to determine if I am the host or not. And we're going to populate those variables later, but this tells if I am the host or not. All right, so those are a couple of references we have in there. So now we can have also the game references. A couple of things that we need to have references to. So the first one is the buttons. So we need to have a reference to the start button. So we can enable and disable it when the time comes. So I'm going to create a serialized field, game object, oops, not private game object, start game button. Later, we're going to drag this reference. But the reason why I want to have this reference here is because I want to turn this button on and off based on if the player can or cannot play. I also want to have a reference to the canvas. Start game canvas. So this is because as soon as everyone is ready, as soon as the game starts, I want to disable the canvas so we don't have the join button and the input text button on the screen. So we can just disable that completely when we want. Another reference I want to have here is the end game canvas. So when someone wins, I can turn that on. And I also want to have a reference to the text inside of the canvas. So when someone wins, I can change the text to you won, you lost, based on who won and who lost. So I'm going to create a text reference to the end game text. And here, to have access to the text, I need to import the UI. So I'm going to use the same thing and just import using Unity Engine UI. So those are the initial references we need to have. Basically, the initial references we need to have there. Check the chat here. See if someone is... Nope. Oh, someone have any questions? So Tommaso asked, will the spawn blocks be synced in position between the players? So not the blocks. We are not going to sync the blocks. We're going to sync the position of the player and the avatar that represents the player and the board. We could sync the blocks too. Yeah, we could, but just for two things. One, sake of simplicity, because we're already syncing other things. And second is, I don't know, like when I was thinking about the game, I thought it would be interesting to not see what the other player is doing. So you don't know if you're losing or winning. But if you want to sync the blocks, it's after this, you're going to know how to sync the blocks too. You just need to like loop through all the blocks and sync their position. I'm going to show how to sync positions of things. I'm not going to use in the blocks, but in other things like the board, for example. I'm going to show how to serialize a position and sync that. So now that I have all of those references, I can go back to Unity and link them all. So let me open Unity here. In my game manager, I need to link a couple of things here. So I need to link the join button. So I'm going to link the join button here. I need to link the start game canvas, which is this canvas here. I need to link the end game canvas, which is this end game here. And I also need to link the text there is here. So I actually linked the join button. That's not it. It's the start button. Let me give this one a name. Start game button. Now we'll link, oops. I'll link the start game button here. Oh, what happened? Start game button here. Not the join, it's the start. So we're gonna enable the start when the player is ready to go. Cool. So now we have most of the elements we need. We can start diving into the multiplayer aspects of the coding. So let me open it back here. First thing, when the user presses the join button, let me remove those for now so we have more space. When the player clicks the join button, I want to subscribe to the network, know when it's ready, and then start the game. So we're going to create for that a public function that I'll call join. Nope, no join break, just join. This function is going to be called by the join button. So every time the player presses, oops, I'm clicking a bunch of things here because my resolution is weird. When the player presses this join button here, I want to call that join function that I just created. So I created a join function and I want to link that to the button. So let me close this so it doesn't come my way. Let me close this too. So let's do that. In the join button, I want to link a behavior. So every time this is clicked, I'm going to select the join button. Every time this is clicked, I want to drive a behavior. So this behavior is in the game manager. So I'm going to drop the game manager here and I will select the function join. So this is binding the events that I created in code with this button. Every time someone plays or presses this join button, is going to call this join function here. And what I want to do in this join button, two things. The first thing is I want to enable the AR networking manager. If you remember, the AR networking manager is disabled. We started with that disabled. So the AR networking manager.enable is now equals to true. So it's going to start processing the network when the user plays or presses the join button. Another thing I need to do, and this is going to be very important, is start subscribing to events. So this is a very concept important in developing in general, but when we're dealing with networking and multiplayer, this is extra important. So we're going to need to subscribe to a couple of events here to know when things happened. So the first event we're going to subscribe to is in the AR networking factory. So this is an Niantic ARDK class that provides a couple of things. One of the things is this event, AR networking initialized. So this event is going to be called when the networking is ready to go, when everything was created internally and the network is ready to go. So we can only start looking into other events if a player is connected, if a player is disconnected, once this one is ready to go. So I'm going to subscribe to this. To subscribe to this, we need to have our specific function that's going to be called when this event is dispatched. So for that, the operator we use in Unity is this plus equals to. And then I can create a function that can have any name. I'm going to call my one on network session initialized. So that's how, oops. On, okay, there's a trick here. If I don't want to type everything, I can just press tab and it's going to create that for me. But it create that with a weird name that I don't want. So I can just rename that. And I'm going to call this on network session initialized. Cool. So this is a little bit weird. I know if you're not super experienced, that looks really ugly. But the way it works is, this is a function I need to create. So I just created this here with the name I wanted to have. And then we're going to subscribe to this event. So the plus equals, we're going to see that a lot, is the operator we use to subscribe to events. So what this thing does is, every time the AR networking initialize is called, it's going to call my function, and then I can do whatever I want in my function. This function needs to be special. It needs to receive a parameter with this big, gigantic name here, which is any AR networking initialize args. Args are basically parameters, things that this is going to tell me when the network is initialized. So here we need to subscribe or to import that class. So I'm going to just use Visual Studio to help me with that. And now it looks good. And I have one more thing here into the top. But basically, when the player presses join, I will subscribe to this event. When the network is ready, then I can start doing things. What those things are? Well, first, these args, if I just type args here, it's going to give me a reference to the AR networking that is already running. So I'm going to store that, and that's why we created this AR networking here. So my AR networking is going to be equals to args.AR networking. So now I have a reference to the AR networking, and in this AR networking is basically where I'm going to subscribe to other interesting events. So here I'm storing a reference to the AR networking. That's what we're doing here. And now in the AR networking, I can subscribe to other useful events. For example, when a player connects, when a player disconnects, when a player sends a message, the bulk of the logic of multiplayer handling. So let's start with connecting. So AR networking dot networking. This networking event gives me lots of, or this network component gives me lots of events. So you can see here, there is the connected, connection failed, data received, deinitialized, disconnected, peer added, peer received. Those are the events that I can listen to in my network to do things. So let's start with the connected. I'm going to use the same logic. I'm just going to rename this to on connected. And I don't like when it adds like this thing, this big thing here. So usually we can just import in the beginning. So basically what's happening here is I am subscribing to an event that is when I am connected to the network. So when my local player is connected to the network, it's going to call this function for me. It's going to call this function for me. And then we can handle whatever we want when the connection happened. So this is the first event we should listen to. I am connected. The second event we're going to listen to is when someone else is added. So that's the peer added. So every time someone joins, I'm going to be notified, hey, someone joined the room. And with that, we can create another function, which is the pair. I'm going to call that on peer added. So now we have two different functions to handle two different things. One to handle when myself is connected and when I am connected, and one to handle when another player is connected. So those are two very important functions we're going to need. Before I move forward, is it making sense? People that are still there with me, just thumbs up, thumbs down. Yes? Perfect. If you have questions, feel free to ask questions. I see some thumbs up. I know it's a lot, but once you understand this, you are able to go from this, use the project and build your experience. So just make sure you understand what events exist, what they do, and the concepts there. Nice. I see people are just thumbs up there. Cool. So let's subscribe to all of the events that exist, or all of the events that we're gonna need and use. And then we can go back and populate the functions with real code. So we already subscribed to unconnected. We already subscribed to peer added. Now, another one that is very useful is the peer pose. Oops. Peer pose. Oh, it's not on the networking. It's on just here. So it's peer pose received. So the peer pose received, it's gonna tell me when my opponent or the other player moves in this space. So I know where the mobile phone or the device of the other player is on the space every time. So say, for example, you're doing a shooting game like the one Steph showed. You want to shoot you want to create a representation so you see where the other player is in AR so you can shoot them. So you could use that for it. Here, we're going to do that to create an avatar for the player. So I'm going to use the on peer pose received. Another one is the peer state receive. And this is going to be super useful and important too. This is going to tell me every time some peer changes its state. What's a state? Well, when they connected, when the device is trying to find them, when they were found, if they're stable or not. So we're going to see that there are a couple of states, and they're very important because I can only start the game if the player is already stable. If they're still finding where they are, if they're still like mapping the environment, I cannot start the game yet in this case here. So I want to make sure all of the players have the correct state. In this case, it's going to be stable. I'm going to show what the states are. But basically, this is going to be notifying me every time that any peer changes its state. And the last but not least callback that we're going to be subscribing to is the peer. And this is again in the networking. Don't ask me why they organized this way, but there might be a reason. This is the peer data received. So this is the most powerful and the most important function, in my opinion, when you're dealing multiplayer, because you can notify any player about anything. So if they scored, if they lost, if you hit them, if you want to make a chat, you can you can just send a text using the broadcast, and then the peer data received is going to be called. So this function is going to be called every time a peer sends me a message, and this message can be anything. It can be data about the game state. It can be anything. And we're going to see how to do that in a while here. So those are the important events. On connected, so this is when I am connected. On peer added, when someone else connected. On peer pose received, if my peer moved, any of the peers moved, and where they are. On peer state received, if they are in a different state in the tracking system. So it could be failed. Like, what if they fail to connect? Then I cannot start the game. So that's why the peer state received is very important. And peer data received when any other data that is not the peer pose is received. Cool. So now we can start populating those and creating some logic for the game in there. So the first thing is on the unconnected, and let me reorganize this because every time I create it creates on the top. So I want this to be the first. So when I am connected, when I am connected, what I want to do is store some references. So those args here, the arguments here, they bring me who is the host, a reference to the host, a reference to myself and tells me if I am the host or not. That's all I get when I am connected. And that's enough for us to start storing our references. We created this variable self, and I'm gonna store my own reference, a reference to myself. I'm also gonna store a reference to the host. The host is the player that is hosting the game. It could be the same. If I am the host, those objects are the same, but that's not a problem. And then I also wanna store if I am the host or not, so I know if I should be doing things or not. So that's all we do. That's all we do on connected. I just store references. But when a peer is added, I want to keep a list of all peers that exist in my game. And we're going to keep an avatar for this player. So what I'm going to be doing now, and let me just go back to the chat here. What I'm going to be doing now is I want to create a prefab or something that is an avatar to represent other players. So I'm going to create here a private, serialized field, a private game object player representation. It could be any game object, anything you want. For now, I'm just going to create a sphere so we can have something to represent the player there. So I'll create a sphere, and this is going to be my player avatar. One thing that is important, again, because I'm going to be instantiating that into the real world, we need to pay attention to the dimensions. So Eli asks, so that game object we instantiate whenever someone new comes into the game. Correct. Exactly. That's it. And I want to track where this person is and show this in that position of the player. So you could, for example, add the name of the player on top of that if you want to do like a nice feature for the game. But yes, you're correct. So this game object is going to be instantiated every time someone joins. And I want this to be small, like 10 centimeters, maybe even smaller, because this is going to be instantiated in the position of the device, where the device is. So I'm going to make it small here. And then in my game manager, I will bring that avatar here, player representation avatar here. So what Eli said is exactly what we're going to do. Every time a new player joins, we're going to instantiate that player. But the thing is, I want to keep track of all my players, all the peers that exist and their representations, so I can update that. So before we do the instantiation, I'm going to create a dictionary or a hash map here. And a hash map is basically a table. So I'm going to be creating a private dictionary. A dictionary needs two types, what goes into one column and what goes into the other column. So we can think about a dictionary as a pair of key and values. So it's like a table. My key is going to be a peer, and my value is going to be a game object that represents that peer. So every time I create a new peer, I'm going to say, hey, this peer has this game object as representation. So I know how to refer to them later. I'm going to just initialize this. And there we go. So now I have this object. It's a dictionary called peer game objects. It's a table that references a peer game object every time. So what I can do now is when I am instantiating that, I can keep track of that so I can update the position later. So here in my peer game objects in the args peer, so this is the key. I'm just saying in this peer that was just created, you're going to store a new game object. So I'm going to instantiate a new game object. To instantiate a game object, I need three things. One is what I'm cloning to instantiate. So it's going to be the player representation that I created. The second thing is where. Right now, I don't know where because the player was just created. The position was not updated yet. Those things are done in two different events. So on peer pose received is where I know the position of a peer. So here, what I'm gonna do is just instantiate that very, very far away in a place I cannot see. And later on, we can update that position. It's a new vector tree. New vector tree, and then a quaternion dot identity. So every time we're instantiating something, we need those things. What I want to instantiate, where, and what is the rotation or orientation. So here I'm just like using no rotation. It's just the standard, instantiating very far away, a player representation, and storing that into this dictionary. So that's all we need to do when we are instantiating a new peer. And now, because we're already doing that, when we receive a new pose, so this is the function that receives a new pose, we can update that pose. So the first thing is I need to know which peer I received. So I'm going to create here a reference to the peer equals to args.peer. So I'm just storing which peer sent me a position. Then I'm going to find that peer in the dictionary I created. So my game object is going to be equals to, peer object equals to my dictionary in the peer that I just got. And then I can create a pose that comes into the args. So in these args here, I'm going to get a pose. And now I have everything I need. So I can change the position of my peer. So my peer object dot position dot transform dot position is equals to the pose dot to position and the rotation is equals to my pose dot to rotation. This pose is a matrix. You can see that is a matrix 4x4. So the way the ARDK gives us this is just one matrix with everything, not only position, not only rotation. So that's why we need to use those two position and two rotation. Those two functions are not part of the matrix class by default. So what Niantic ARDK does is create an extension method for that. So we're gonna need to import something here in the beginning, which is the utilities. So it's gonna be using niantic.ardk.utilities. So in these utilities, there are many things. One of the things they do are extending the matrix for. Isn't it the utilities? One sec. No, it is, but I'm typing that wrong. It's to position and to rotation. There we go. So if I don't have the utilities here, let me comment that out. This is not going to work because those functions are not part of the matrix. But then what they did was just create an extension methods to provide those utilities in there. So, okay, Indica, change the pose, okay. So just providing more explanation there. But that's it. So now we have lots of things going on. They're cool already. Every time a new peer is added, we create a game object that represents that peer, and we save that into a dictionary. Every time this peer moves, we store or we find that peer again, we see where it is, and we update that position. Does it make sense? What was the question? Because peer updating is asynchronous. Yes, it is. It's asynchronous and it's not super reliable. So it gets in any order. That's why we need to have an event. Whenever it happens, we find the peer and update that. It's unordered. It's asynchronous. It's just event-based. If that makes sense. Cool. Perfect. So now we want to start our game. But remember that I told that we can only start the game if everyone is ready to go. So we need to keep the state of the players. So what I'm going to do, and we already know the dictionary, we already understand the dictionary. I'm going to create another dictionary just to keep the state of the peers. So it's going to be super similar. It's going to be a private dictionary iPeer. But that this time is not going to be iPeer game object. It's going to be iPeer peer state. So the peer state can be, it's an enum, so it can be unknown, initializing, waiting for localization, localizing, stabilizing, stable, limited, fail. What I want here is only when all the players are stable, I start the game. So to know that, I need to keep track of the peer states. So I'm going to call this peer states. And it's going to be the same thing. So here I keep the states. Here I keep the objects. So the place for us to update the state is basically when we receive a new state. So let me move this here. Let's go in order. Every time I receive a new state, I'm going to update that list with the states. So it's going to be very similar. I'm going to get a reference to the peer from the arguments. So this is basically who is sending me a new state. Oops. Who is sending me a new state? And then we can create a new state equals to args.state. So this is who is sending the state, and this is what state they sent. And then I will add that to the dictionary. So my peer states in the peer position is equals to the new state. So basically what I'm doing is every time someone sends me a new state, I go back to the dictionary and update that state for that peer. So basically, if player one, we're playing with two players. So the way it looks like is like this. So if the first player sent failed, and then this is the peer, so it's player one, and then it's gonna be failed. And then if the player two sends stabilizing, it's gonna be stabilizing. But if it changes at some point, so say for example, the player one is now stable, it's gonna send these states again. We're gonna go in the dictionary, find where player one is, and change this state to the new one. So now I have a dictionary with the most recent states for every single player in the game. Does it make sense? And now what I want to do is verify the game logic. So I'm going to create a function here. Let me create a function, verify game logic. Every time someone changes, I want to call that function. If anyone changes state, I want to call that function. What this function is going to do is tell me if I can start the game or not. So a couple of rules. First thing, if I am not the host, so if I am not the host, I don't care. I'm just going to return. Why is that? Because no, is host. How did I call that? Is host, yeah. So if I'm not the host, I'm not checking for the logics. I'm just waiting for someone to tell me. The second thing is, if I have less than 2 players, I also cannot start yet, because in this game, we want to have 2 players. So if I didn't receive 2 different states, I'm gonna return 2. So I'm not doing anything. Return basically exits this function without processing anything. And now, the next thing I want to do is basically check if, now that I know I am the host, I know that there are 2 players, what are the status of those players? Are they in the stable status? So we can loop through all of the players and determine if they are in the stable status. So I'm going to be using the values in my dictionary. So looking into all of the values there, and I need to make sure all of them are equals to stable. So there is an easy way to do that with LINQ, which is using item if item equals to player state, here state dot stable. So this all, basically what it does is it's going to verify a condition for me. So the condition is every item, so for every item in these values here, are they equals to stable? So if a single one is not true, this is not going to be true. If all of them are true, this is going to be true. To use this all, we need to import LINQ. So LINQ is just like a query, something to help us write less code to do the same thing. Instead of like doing a for and checking one by one, we can just use this all statement there. So what's happening here is if all of them are ready to go, I can enable the start button. So we have the start button reference. I'm gonna make that set active true. So now we can play on the start button and start the game. Does that make sense? Cool. So now we're getting almost there. We're getting almost there. So now what the start button needs to do? Well, first, let's create a function here that is called by that button. So I'm going to create a public void start game. This function, what it's going to do is first disable the canvas. So disable this the canvas we created, the start game canvas. We don't need those inputs anymore because the game already started. So this is going to be false now. And I will create a Boolean just to tell me if the game is running or not. So it's going to be a private bool is game running. It starts at false, so it's not running. And then when I click on the start button, it's now true. So we can use that to instantiate things and to start the logic. We need to hook this into the button. So I'm going to go back. I'm going to go back into my start game button. And I will link that behavior here. So I'm going to bring my game manager and link the start game behavior. There we go. So now that will be the time when I will build everything to the device and test in multiple devices. So we see if the things are working or not. That would be the best way to do it. But I'm not going to build now because it takes time. But I will show you one thing that is very cool that comes with the Lightship ARDK that helps us to test better. So one thing we can do, I'm going to go here on assets and right click, go on to create. And then there is this ARDK mock play configuration. So this allows me to create fake players. So I want to create one fake player, for example. I can give it a name just to test. But basically, I can check if this player is using AR, if he's using network, if the networking is activated for this player. And then one thing I can do is I can hit play. The editor is going to be one player. So the editor is one of the players. If I go into Lightship ARDK Virtual Studio, Here I can bring the player configuration I created, and then my fake player is here. So now I can, let me use here, for example, this is going to be my key. I click join. And here I can change my states. So I can make that stable. And I can make the other player stable as well. So I can see the code moving. So right now, just by doing that, I realize there is an error somewhere. Let's see what that is. Did you create the player scriptable logic? No, it's part of the ARDK package. It's part of that. So you just need to right click, go under create, net ARDK, and then it's here, mock play configuration. I didn't create it. It's part of that. So you just need to create it and give it your what you want to add there. I have an exception here. What's going on? What's going on? Mock AR networking session. Peer state. Oh, I think I was in play mode already. So I need to bring it here before I am in play mode. And then I can add this. Let's see. Yeah, there we go. It's still complaining about object. Object reference not set to an instance of an object. That's internal. What's going on? Did I miss something? No, this is okay. This is okay. This is also okay. Oh yeah, I forgot to tick this, so I found it. So here in the networking session manager, I need to tick this use with AR networking session. So they work together. Basically, that's it. Let me hit play and try that again. So this, I'm gonna use this. There we go. So now this player is connected. And I can go here into the virtual studio and connect another. So this is my local player. I can fake the state, so I can say it's stable, and then I can run and join my other player and also make it stable. So when I do that, we can test all of the events. We can test if the events are being called and if the states are being called and all that. So this is pretty cool. Cool. Okay, so Indica just posted that what the status look like waiting to localize, what they mean. But yeah, that's good. And then when everyone is stable, it means that it can go. Cool. So now what we need to do is instantiate the board. So basically we need to instantiate the board because the game is already running. So what I'm going to do is I will create 2 more references here. One reference is going to be to the board prefab. So it's going to be a private game object board prefab. And the next one is going to be my own board. So it's going to be a private game object, just board. We already created a prefab for the board. So I'm going to go back into Unity and drag that. So into my game manager. Now I'm going to have one more field here to bring in the board that I created. So I'm just going to bring the board. Why I cannot? Oops, I created the wrong type. Oh, no. So this is not game manager. This is game object. This is game object. This is game object. And now we can drag it. So I'm gonna drag the board here. There we go. So now what we need to do in the update function is check if the game is ready to go and if everything is ready to go. So I will create a update function here. The update function runs every frame, and we're gonna do the logic to check where if we should instantiate the board or not. So first thing I'm going to check is if I am the host. So if I am the host and the game is running, and the board does not exist. So the board is equals to null. We only want to instantiate the board once. That's the only thing we want to do. So what's complaining? Cannot be. Oh, it's is host. There we go. So here we need to handle the touch. So I'm gonna check where the player is touching, trace array from that into the plane, and then instantiate the board in the position of the plane. I'm not gonna type line by line here. I'm gonna copy that from another project and just go over what's going on, because otherwise we're gonna run out of time. But I'll make sure to explain what's going on. So first thing we need to do is check how many touches are on the screen, or if someone is touching the screen. We need to check first if there is a touch on the screen. There are many ways of doing that. One way I've been seeing that in ARDK is using a class they created called platform agnostic touch. So what I like about this is it can handle Android, iOS, and PC. If you click, it doesn't matter where the touches are coming from, they're gonna give you this number. So if it's touch, if it's mouse, it doesn't really matter. So it just makes it a little bit easier for us. And then I'm gonna get this touch. So my touch is gonna be equals touch is gonna be equals to touch dot, no, just platform agnostic input dot get touching 0. So this basically I'm getting the first touch on the screen. If there are 10, it's just ignoring the other ones and getting the first one. So now I need to get the camera frame, the image that is being rendered, because the mobile is moving all the time. I need to get the position where the touch was done in that specific frame. So first I need to get the current frame. And I get that from our AR networking session .ar session .current frame. So this is basically the current frame in the AR session. And then it might not exist because it's not super reliable. One frame can be skipped if the device is running slow or something like that. So if I don't have the frame reference, I'm going to need to wait until the next frame, which usually is not a problem. But I'm going to skip the frame here. And then what I want to do is basically a hit test. See if in the position where I touched, there is some plane. There is some plane existing there. So the way we're going to do that is using the current frame dot hit test. So there is this function called hit test that basically does the hit test for us. We need to pass the dimensions of the camera so it can calculate that correctly. I'm gonna use the camera.main.pixel width and the camera.main.pixel height. And touch position, so basically where I touched, and what kind of planes I want to use. So here we're going to use, it's getting small. Let me break this down here, down here, down here. So there are many different ways of getting the plane. The most reliable one, and because we're using the plane tracker, is the plane using extent. So it's gonna basically find a plane in the extent of what the camera is looking. So basically, what's gonna tell me is every single plane that is being hit by my touch. So I touch in a specific position, it casts a ray, see where it touches. First thing that can happen is it doesn't touch anything. So if my results dot count is equals to 0 or less than or equals to 0, it means that I'm not touching anything. So here we're gonna skip and wait for the next frame. So basically, no plane available. Otherwise, if you found a plane, we're gonna get the position of that plane. So we're gonna just get the first one, the closest one, because we can hit multiple planes. I'm gonna get results in 0, which is just like the first plane I hit. And then I'm gonna get the position of this hit. So hit position is equals to my result dot world transform. So it gives me the boundaries of the word. This is basically like a matrix that defines the word. And there is this to position because I only want the position. And now it's just basic Unity things. I can instantiate my board. So my board is equals to instantiate my board prefab that we created there in the hit position that we just calculated with the identity, regular identity. I'm not gonna rotate it. So now basically what I'm doing is checking if there is a touch. If there is a touch, I get that touch. I get where it's corresponding in the image. I see if there is a plane underneath that touch, and then I create a board in that position. But then there is a problem here, which is this only instantiates into the host, right? Because this position is being tracked for the host by the host. So now we need to inform all of the other players that this thing happened. And this is where the things get a little bit interesting and also a little bit annoying, I must say, because you can only send an array of bytes. You cannot send a vector tree. You cannot send a game object to the internet because, well, it's heavy. You can only send bytes, zeros and ones. So I want to notify the other players where to place this board, but I need to serialize this position somehow. So this is a very important concept when you're sending message to the network. So message need to be array of byte. That's what we can do. That's all we can do. So let's see how we can do it. It's a little bit scary, but it's not that bad. So the first thing is serializing numbers is a little bit harder than serializing strings. So the first thing I'm going to do is create a string, a text that I can convert into bytes and send. So I'm going to create a string vector equals to, it's going to be an interpolated string. I'm going to show how that works. And here in this string, I need to place X, Y, and Z. I need to send the X, Y, and Z of my position. So I'm going to add my hit position dot X. I need to have a separator because on the other end, I'll need to know where the X is, where the Z is, and where the X, Y is. So you can like use any arbitrary separator. I'm going to be using the pipe here, but you could use any. And then I'm going to pass the hit position Y, another pipe, hit position dot Z. So this is super weird. I know what I'm doing here is just creating a text that has X pipe, Y pipe, Z. The reason why I'm doing that is because I can serialize this string into an array of bytes. And on the other end, I can deserialize that and split that by pipe. And then I know what's going on. So now that this is a string, I can create a byte array. That's the only thing we can send through the network. It's an array of bytes. And there is a function in C# into the encoding class, encoding.ascii.get bytes. So what this function does, and encoding, and I will need to import the class system text. Oh, I was writing that wrong the whole time. So basically what this does is converts a string into an array of bytes. So that's the only message we can send. It's an array of bytes. There are other ways of doing this. I'm just doing that the way that is simple as possible. Now I can send this message to all of the other peers and say, hey, create for me a board in this position. So the way we do that, and this is a very important thing, is AR networking dot broadcast data. So broadcast data is going to send data to the other peers, and it's going to call the on peer data received callback. So that's how you send message from one side to the other. This function requires 3 things at least. The first one is a tag. This tag is random. It's just like a number that is going to identify what kind of message I'm sending. So here, for example, I'm going to say that 0 means instantiate the board for me. So it's an arbitrary tag just for us on the other end to identify what's being sent. So that's it. This is the first thing. Second thing is what message I want to send. This is going to be my array of bytes. And the third one is what kind of transport type I want. This is basically how reliable I want this message to be. If you make that reliable ordered, it means that it's going to make sure it delivers the message to the best extent, and all of the messages go in order. So this is not the best. Like, you can use that in specific situations, but most of the times you don't want that because it's going to delay other messages and things that are not important. Like, I can receive that at any time. It doesn't matter. For example, the position of the other player. It doesn't matter when I receive that. If it's unreliable, that's okay too, because if I miss one frame, I update in the next frame. So basically, those are how reliable you want the message to be. This is going to change the internal protocol and a bunch of things. So for this case here, I can just use unreliable ordered. Why ordered? Because this is the first thing that happens into the game. So I want to make sure they receive this in the order I sent. So if I sent, for example, another message, it's not lost. It could be unreliable. It could be reliable here in this case. But let's just go with unreliable order. It's going to make sure that it's sending through UDP, but it's going to be ordered. And that's it. So this is how you send message. And you can send anything. You just need to make sure you convert that into an array of bytes. Does it still make sense? Any questions? Jacob asks, thanks for answering my question. I don't know what the question is. Can you briefly explain what is high versus low level? I missed that part. I don't think I touched on the low level and high level APIs. So ARDK has 2 different APIs that you can use. One is high level and one is low level. The high level is basically what we're using right now, where basically the networking is completely handled by the APIs they have, and they have those high level functions. And the low level, you need to determine a lot more than we're doing here in terms of how the messages are sent and whatnot. You have a lot more control, of course. You can do like massive multiplayer games, but the high level and the low level, they're just like, the high level is easier to program with and it provides lots of functionality, but it's less flexible and it might be slower too, depending on what we're doing. But we're doing everything using the high level. But yeah, so this is how we send a message. Now we need to see how we get the message on the other end. And that's the last thing we're going to do. So now for the other player to instantiate the board in the same position, what we're gonna do is on the peer receive some data, we're gonna see what kind of data is that, and then instantiate the thing. So first thing, we are sending a tag. So I'm gonna check the tag. So if my tag is equals to 0, just because I determined that in an arbitrary way, we're gonna say that this means that I need to instantiate the board. So 0 means I need to instantiate the board. That's basically this. So here I will need to get the array of bytes that we created. So we can use the args.copy data. It's gonna copy the array of bytes to my variable. And now I wanna make that from bytes back to string. So I'm gonna use a string vector equals to same class we used, encoding, dot ASCII dot get string. So what the get string does is basically converting bytes to string back. It's the other way around. But now remember that this is string, it's basically separated by it's a string separated by the pipes. So I need to split that. I'm gonna create an array of string that I'll call parts. They are parts of the array equals to my vector dot split. So the split receives a character, a char, which is basically what is the separator. So now this is gonna be a vector with 3 elements, 3 strings with X, Y, and Z. Now I can make a vector tree from there. So vector tree equals to a new vector tree. And here I need to pass X, Y, and Z. So it's gonna be my parts in 0, my parts in 1, and my parts in 2. But the problem here is, this is a string, this needs a number. So we need to convert a string to number. And then there is the float dot parse. So the parse basically transforms a number that looks like a float into an actual float. And here I'm pretty sure it's gonna work because I was the one building that string. So it's just using our standard. And that's it. So now it's just like instantiating the board in the same position. So my board is equals to instantiate board prefab. The vector tree I just assembled, and the quaternion dot identity. So now that's it. We have connection. We sync the states. We know that the players won or not. Oh, no, we don't do that yet. We know if the player is ready to go, and then we start the game. When the main player, which is the host, instantiates the board, we tell the other player to also instantiate the board. So that's all. The only thing we didn't do here, and I'm not gonna type that just as a matter of time, but I'm gonna show in the finalized project. The only thing that is missing is telling it who won, if the player won or not. So let me show you how I did that, and then you can go into the project and check that as well. So I have a ready project here, and I'll show this. So this is exactly the same project. In the board, I created another behavior. So if we go here into the board, this is the board we created in the beginning. I created a border in the top just so we can detect if the block got there or not. But in the board, there is a very simple script. So what this board does is it finds the game manager, and then it checks if that's the host or not. Only because I want to assign this area to one player and this area to another player. So in the spawn points, there is a tag for each player. And basically what I do here is a very simple association of, okay, if I am the host, I get the spawn point with the tag player 1. If I am not the host, I get the tag with player 2. So that's very simple. There's no network involved. And here on the update, no network involved again. I'm just checking if I'm tapping on the screen. If I'm tapping, I will instantiate a block. So, and the block has a rigid body, so it's going to be falling. The last network piece that we have is basically on this border here. I created this script, victory detection. So basically what it does is very simple. On trigger enter, when a box goes into the area, it gets the game manager and call this function notify victory. So what this function does is very similar to what we just did. We're calling the broadcast, we're calling the broadcast message again. Instead of 0, now I'm using 1, a different tag, arbitrary tag, just saying that 1 means someone won. And then I'm sending who won as the array of bytes, and that's it. So I said reliable ordered, and this last parameter here is if I want to send that to myself as well. And in this case, I said true. I want to notify even myself that someone won, so we can handle the code in the same way. So because we're using the broadcast data, we already know that this is going to call the on-peer data received. And the difference here is, well, tag 1 instantiates the board. If it's tag 2, I'm pausing the game, I'm enabling the interface, and then I'm checking who won. If the peer that sent this message is me, it means that I won. If the peer that sent that message is not me, it means that I lost. So it's kind of the same logic. If you want to have more message that you send, for example, power up or whatever, you just need to add more tags and check against those tags. But that's basically this. That's basically this. That's what you can do there. I'm gonna share the link for the finalized project one last time. You can download it. I want to see you running that on your devices, modifying that, adding more behaviors. If you have any questions, feel free to ask me. I'm gonna be here for the Q&A as well. I know it was a lot. I know it's very difficult to get everything that's going on, but I hope you could get at least the concepts of the session networking, what the components are, the events, and then from here you can build anything you want. So I'm gonna stop here, invite staff back, and I will be answering the questions if you still have them. There we go.
Hello. Thank you, Jerry. Can you hear me, see me? Is everything all right?
Yes.
Perfect. Lovely. Well, thanks everyone for hanging in there, checking all this out. I hope you all learned a lot here today. I'm going to toss in a poll before I just wrap things up and go into the Q&A session, but curious to know your thoughts about this webinar and workshop here. Was it helpful? Was it not helpful? So if you could go to the polls tab, I'm going to toss in a poll here. It's going to ask you, on a scale of 0 to 10, how likely are you to recommend this workshop to others? 0 being you wouldn't tell a soul, 10 being you would recommend it to others. So I'm going to publish the poll here. Please do check it out. And thank you again, Jerry, for handling that session there. And we'll take about 5 minutes or so to wrap things up, and then we'll open it up for Q&A there. But let me share my screen here quickly. All righty, perfect. So just to wrap things up, again, if you are interested in diving into this further, building the skills to be a developer or a designer, we would love to help. Now, we at CircuitStream have a variety of different programs to tailor to your learning needs and goals and what you're looking to do. And we cover development, design, and even Unity in general. So diving into these really briefly, we have our XR development with Unity course. This one's live and online, instructor-led, 10 weeks long with up to 8 hours of instruction per week. Our next cohort's on October 4th, and how we approach it is that there are 2 live sessions in classes, an hour and a half each class for a total of 3 hours of instructor-led teaching and learning. and then daily open office hours as well. Now, you'll come out with several portfolio pieces to show for and industry recognized certifications as well. Beginner friendly and really tailored to development, programming, scripting that we saw here today. So if this was all new to you, or if you still need to build on that, this is the one to really look into. Now, we also have a design focused on user experience, storyboarding, prototyping, user testing, our interaction design and prototyping for XR course. Now, similarly, 10 weeks long with up to 8 hours of instruction per week. 3 of those hours are in class, and there's daily open office hours for additional support as well. This also has projects you can come out with and show for, certifications available. And for these 2 programs and the one I'll be covering soon, feel free to check out those university partners. If you want to go through a university, get a certification there as well. Please do check it out. We'd love to speak with you. And it's September 28th for anyone who's interested on the design side. No coding, no scripting, really focused on design and that user experience. Again, for these 2 programs, no experience required. So beginners, have no fear. We welcome everyone from all walks of life. And we've got a wonderful community as well. Again, daily open office hours, networking with hundreds of other alumni that have been with us, those who are currently learning with us, and various events from coffee hours, demo days, show and tells, and speaking sessions with industry experts as well. Now, if you're looking to really kickstart a career and nail down those skills to be successful, we have our Unity Developer Bootcamp. Now, this is more intensive, live and online as well, 24 weeks long rather than 10 weeks long, with up to 16 hours of instruction per week. Now, there are 2 2.5-hour classes alongside your classmates, dedicated career services, challenges, private one-on-ones, open office hours as well. And every Saturday, weekly labs with various leaders from different companies who really just share their insights with you, their experiences, and help prepare you for the future of work. So if you're interested in those, feel free to reach out to ourselves or to the universities. We'd be more than happy to talk about it and to chat. Now, if you want to learn more about the bootcamp specifically, we have an open house and information session on September 8th at 12 p.m. Pacific. Now, this is really for anyone who's looking to learn more about it, ask questions to the team, to the instructors, and we'll be joined by some companies to really hear their side, why this is a great program and the value of the skills learned. Now, as a thank you to the community, anyone who joins live to that open house there will be, how would I say, enrolled or eligible for 1 potential full scholarship. So it's a full tuition and 2 half scholarships, 2 half tuitions essentially, for anyone who comes to attend live and passes the aptitude test. Now, this one, you do need some foundation in Unity, hence why there's a test beforehand. But again, 1 person who attends live will get a full scholarship, and 2 others who do attend live will get half scholarships there. So if you're interested, register for the bootcamp open house launch there, and we'd love to see you. We'd love to have you and answer any questions you have. Now, for any of these courses and programs, we do have some flexibility, 3, 6, 12-month payment plans for international students outside of the US. And for those in the US, Climb offers loans and payment plans as well. So check those out. You can find them on our website or speak to the team for more information. But that's the wrap up here. Let's invite Jerry back to the stage, see if there's any questions we may have missed or any, last minute questions or questions that haven't been brought up yet. So, hey, Jerry, great seeing you again.
Hello. I think Indica did a really good job answering complicated
most of them.
Here. Yeah.
yeah. But let's see if there's anything else hanging here. So I think most of them have been covered. Let's check out the chat here. Anything in the chat? Reply to the question. Weird. Okay. So doesn't look like there may be.
He answered everything.
Yeah, I think so as well. No, this is wonderful. So we can take a couple of minutes here, see if there's any last minute questions. But Jerry, awesome presentation there. It's a lot to digest. But again, we are sending this to everyone afterwards to check it out if there is anything you wanted to review. But I'm just going to scan over the chat here, see if there is anything else that we may have missed. I know Ilya said he missed the first part, but we'll watch that first hour replay. And Chanel did share a survey link here in the chat. So for anyone still tuning in, do check out that survey. Click on it, fill it out. It's 1 minute long. That would be super helpful for everyone to know whether or not this was beneficial. But
there is just a last question from Eli there. I like it, and I want to answer that. So he asked what I am most excited about Niantic. It's a really good question, and well, I worked with AR for a long time, and honestly, it's the most powerful tool available there, because if you want to use like meshing or meshing is like detecting like contextual awareness in other platforms, you need to have a really good phone. Like you need to have an iPhone Pro with LiDAR and whatnot. If you're using most of the other platforms out there. But with Niantic, I can do that with my very old, crappy Android that I have here, and it runs really well because they have lots of strategies behind it, but it's very complete, and the technology is really, really amazing. I haven't seen something like that. Like you can do proper contextual awareness using that. And because it runs into Unity, another thing that I like is when we have like other devices like glasses, that's gonna be available as well, and I think it's gonna be more flexible. And the multiplayer piece that we are doing right now here, it sounds a lot complicated, but if you try to do that, like mixing AR plus sharing the world and synchronizing that in any other tool, it's gonna be a nightmare. It's gonna be really hard. So having the shared AR experience that does proper tracking, even with low-end devices like my Android, I cannot do most of the workshops with this Android because the plane tracking just doesn't work. But with Lightship, it works, and it works really well, and it detects even like vertical planes that I cannot do with AR Foundation, for example, or with Fufoya, for example. With this phone, I can only do very simple horizontal plane tracking. But with Lightship, it works really well, even this old phone. And now with the VPS, the Visual Position System, I think that it's just bringing AR in context and plus social. So I think it's useful. Like I've seen so many applications that are right away useful and games that are super fun. And they're just not like for the sake of the technology as sometimes I see in other tools. So I really believe it's going to like explode. It's going to be one of the most used AR platforms or AR SDKs in the future. It's super, super powerful. If you haven't messed up with that, just get the templates, like the simple examples, and play with them in your phone. You're going to be blown away by what it's possible to do with that. So yeah, it's a super powerful tool. It has been developed for a long time with the games they had with the Pokemon and Ingress and all that. So now it's just like all of the expertise coming into the hands of the developers, which is really cool. So yeah, it's crazy powerful. If you haven't experienced with that, and if you just had like AR Foundation and Vuforia experience, you're gonna be blown away by what it's possible to do with a simple click, like few clicks.
Perfect. Thanks for sharing, Jenna. Yeah, Ilya, nice. Maybe an upcoming circuit stream course. Yeah, stay tuned, Ilya. I know you're always on the lookout there. But I see a Steve. Steve commented here as well, Jerry. I could read it out for recording sakes. Steve was asking, if there's nothing else, can you speak more towards the potential viability of integration with Oculus 2? I'm curious if the B&W, black and white, I assume, and lower quality depth of the current cameras would be sufficient. But then again, I don't know how it handles the environment awareness with other cameras. I know Project Cambria is coming to go to color pass-through and better depth, but with the grip on the market that Oculus has on head-mounted displays at low cost, it'd be interesting to see it leveraged. Great question there, Steve.
Yeah, it's a really good question, and it's a complicated one. So the first thing is, in terms of viability, I don't know. I haven't tested that. I do not believe it will work because it uses it could work maybe. That's a good question. I would test that and let you know if it would work with the pass-through or not. What I know is that the quality of the camera is really low and it's black and white, as you mentioned. So the experiences are not that good. I have seen some workarounds and some hacks that people are doing to use pass-through, color pass-through, like adding a different camera on the Quest 2, which is something I want to try to. So that could make that work a little bit better. But that's a good question. I think that's possible because, like, if you see other tools and platforms that are now working with pass-through, for example, Shapes XR works nice with pass-through now. MRTK, Microsoft HoloLens toolkit or mixed reality toolkit, it works with pass-through. So I haven't seen anything, but that's gonna be my challenge. I'm gonna test it and see. I believe it would work to some extent, but I might be wrong.
Right.
I don't know. I would need to test it.
Perfect. No, that makes sense, Jerry. Thanks for sharing your insights there. And Steve, great question as well. I see Dayon, shouted out. We do have another workshop next week around MRTK for anyone interested. But Steve, anytime. Hopefully that was helpful. No, I'll wait another minute, see if any last questions do come through. But if not, Jerry, again, the man, the myth, the legend, thank you so much for taking the time to go through all of that. It was super helpful. For those of you who are still tuning in, if you have any questions afterwards, feel free to reach out to Circus Stream, to Niantic on the Discord channels that were shared earlier. Reaching out to our teams, we'd love to speak with you and help you any way we can. But it looks like there are no more questions or comments. So big thank you to Niantic for supporting this webinar and workshop, and everyone backstage as well who have been answering questions and really kind of engaging with the chat. And to Jerry, thank you again for all of your wisdom and knowledge shared today.
All right. Thanks, everyone. I am on Discord. I am on both Discord. So if you're on Circuit String Discord or on Niantic Discord, I'm there. So if you have questions, anything, feel free to ping me there too. And I hope to see you all. Bye.
Perfect. Take care, everyone. Thanks again. Bye.